Okay, can everybody see my screen?
Yeah.
Okay, good. Easily, Pendleton?
Yes.
Okay. All right. Well, we're gonna go over some problems today. I didn't assign any homework, so y'all had the weekend off. You're welcome. And we'll work some problems today, and I'm gonna pull some problems out of the book, which really sucks, but it's all I can do because I don't like fooling with that notebook right there. So let me see. Last week, I want to make sure what we went over last week. Oh, yeah, here we go. What was the last problem we did last week? Somebody tell me what those. I know we covered area between curves, correct?
Yeah, we were talking about average in the last.
Okay, the average. Okay, so there we go. So let me. What was the last one we did? I'm sorry, what?
X squared, and then it was like 1,4.
Okay, there we go. I got one or two more I want to do. Hold on just a second. Let me. Okay. Let's go with f of x is equal to 1 over x. And we're going from 1 to 3. So I've given you the A and B. I want you to find the area, or the area region, or whatever they call it in this book. It's where you do the formula, the average value of function. So go ahead and do what we did. Just continue. Use that example that we did, x squared, and find the average, and then find the x and the y of the average. 1 over b minus a times the antiderivative of ab f of x dx. I'll write the formula out here, and you should follow that example that we did last time y'all were here, Thursday, I think. So area of the function is equal to 1 over b minus a times the antiderivative a to b of f of x dx. Okay? Let's take a minute or two and crunch that out.
What up, dog? Cracking.
Oh, Lord.
What's going on, Hubert?
Get to work. Already got one on the board for you.
Oh, we're starting quite early this morning.
Well, that's what happens when everybody's quiet.
Oh my gosh, I don't like this garbage.
Yeah, exactly.
We need to make some noise.
it does. It just really sucks. So, somebody tell me what the first step is before we do the formula. We need to rewrite what? The function, Hubert. That's right, class. X to the negative 1. Therefore, we're actually taking the antiderivative of that. So A is equal to 1 over 3 minus 1, antiderivative of 1 to 3 of x to the negative 1 dx. Now it's when you're supposed to be saying, oh yeah, I remember doing this last week. Good. So equals 1/2, and that's going to be x to the what? Well, this is 1 over x. What is the antiderivative of 1 over x? Natural log of what?
S.
Natural log of x. Now, what's natural log of the absolute value of x? Because you can't take the absolute value of what? I mean, you can't take the natural log of what? Negative. 1/2 natural log of 3 minus the natural log of 1. I think the natural log of 1 is 0. Is it not? Somebody check me. So that's going to be 1/2 times the natural log of 3. Somebody tell me what that is. I'm sorry, what?
0.55.
0.59?
0.55.
55. Now that's going to be our y. So if that's our y, we plug that in for y, and we get 0.55 equals 1 over x. Multiply both sides by x. 0.55x is equal to 1 divided by 0.55. And somebody tell me what x is equal to. What's 1 divided by 0.55?
1.81.
1.81. So our point of area is at 1.81, comma, 0.55. We'll call that our point of area. Okay? So, when we're talking about, where is the sheet I was looking for? Okay. A function, I'm looking for something, y'all, just bear with me. Okay, there it is. What was the last difference of, or area between curves that we did? Was it x cubed? And
I think so.
Okay, good. All right, we covered all of those. All right, so the two things that we're going to be adding besides the basic derivatives and the basic antiderivative rules are the area between two curves and the point of area. So today we're just doing point of area, and I went through the book. Well, I went through the thing they call a book, and I picked out some problems, and we're going to work on those today, and heaven help us, we'll do the best we can with them. All right, so here's the first one. Find the area between two curves that do not intersect. F of x is equal to 0.17x to the third minus 2.75x squared plus 9x plus 30. And g of x is equal to 0.15x squared minus x plus 3. And they want you to check the area between 1 and 9. All right, so this is just finding the area between curves. This is not anything to do with the average. We're going back and forth. We're going to, do two. We'll do 2 or 3 of these, and then we'll do 2 or 3 of the area. The average again. Y'all ready for the latest Tri-County Tech prehistoric T-Rex? What happened? Where is Pendleton? Okay, there's Pendleton. What happened to my screen? When did it do this? I had it on both screens. Didn't I not? Damn Russians. Anyway, I'm on one of the interviewing committees to hire 2 math teachers. Okay, y'all ready for this? And guess how we're doing the interviews?
Through Skype.
Wow.
Through Skype. I got it to where we could do this through Skype. I suggested it and I had to fight. And you know what I have to do to go to the meeting today to go through Skype interviews?
What?
I have to go to the Pendleton campus. Shows you what I have to work with. I finally get them to do Skype.
Do they just
The
want to be with
DAs
you
don't
through
even
the
realize
process?
that you can do Skype meetings from your desk. Okay, we'll meet here at 3:30 or at 2 o'clock. And I said, wait a minute. Why do we have to meet here? We're doing Skype. Well, I think it would be best if we met here. Y'all see what I have to work with?
Some shit, man.
It's retarded. It's like live PD people I'm working with. Oh well. I thought y'all would get a kick out of that. All right. First of all, we need to graph these guys. Okay. I have a feeling that the x cubed is going to be the higher function, but let's just look at it and see what happens, because you got to get used to graphing these things, especially in business and marketing. These funky decimal type quadratics, you got to get used to it. So let's go ahead and take out our handy dandy calculator. I'll pull this over here like this, and then we'll pull it down here like this, and graph y is equal to 0.17 x to the third minus 2.75 x squared plus 9x plus 30.
It's all up top.
I hit the arrow. I hit it twice. Sucks. White women. It's their fault too. All right. And they didn't even do this right. Minus, insert. There we go. 2.75x. Thank you for telling me that. Thank you, one person out of 15. Thank you. Plus 9x plus 30. Is that good? All right. Y is 2. I'm going to make it a little bit darker. We know it looks like a freaking parabola, but let's make it darker just to make sure. 0.15 x squared minus x. I'll get there eventually, y'all. Minus x plus 3. And graph And of course, it looks all funkified. And they're wanting from 0 to 9, so we're probably talking, or from 1 to 9, we're talking probably this area right in here. Let me zoom out a little bit. Unless somebody's got a window configured to where I can just punch it in. I could do a zoom fit. I didn't do that, but let's see what it looks like. Okay, there we go. And where's our other? There's that function. So I'm going to go to Zoom Box. I'm a CAD person, so leave me alone. Let's go here. Go right there. I'm going to hit Enter. I'm going to go down. Make a BA box. And I think that's probably, let's see, that's 18. Let's go to 10, because we're only going to 9, right? So there's 11.9. That's close enough for government work. And there we go. So 1 to 9, we're talking, say, trace. Somewhere right there. Okay, so if you were drawing a picture, that where that cursor is right now, all the way over to 9, so we're probably talking about 6, 7, 8, 9. Right there in the bottom of that valley right there. So of course, I would draw on there, but then I'd have to go to, it's just, I can't, I gotta go to transparency and I can't draw over there, so I'm just not gonna do it. All right, so we got a graph that looks something like this, and like that, and like this. And they want to know from 1 to 9. So that's what they're wanting. What is that noise?
What noise?
The noise, it sounded like somebody was watching something.
I hear it now.
Must be Mr. Miller's porn going off. All right, so we're at 1 to 9. He can take it. He's done.
That's not me. There's no way.
I figured I'd get some kind of reaction out of him. Hey, no way.
No.
All right. Well, I don't know what it is. There's something going off. Somebody's movie or something. All right. So we know that this is your higher function. This is your f of x. And this is your g of x. So let's go ahead and take the antiderivative from 1 to 9 of 0.17 x cubed minus 2.75 x squared plus 9x plus 30. And we're going to minus dang old 0.15 x squared minus x plus 3. Of course, that minus symbol is going to make this a what? It's going to make that a minus, make this a plus, and make this a what? A minus. So once we distribute that, we can actually get rid of that and distribute the positive 1 right there, and we can get rid of that. So now we've got the antiderivative from 1 to 9 of 0.17 x cubed minus, well, what is, somebody take, that'd be negative 2.9, somebody check me, negative 2.9 x squared. All right, 9x plus 1x is what? 10x, Hubert. Thank you, class. And 30 minus 3 is what? Dx. Okay, now, do your thing. Do your calculus, because at this point we haven't done any calculus yet. Interject the 10% calculus, and then keep going. Mr. Miller, I'm sorry I used you as a guinea pig. I was just trying to wake some people up.
No, you're good. It might be
I
my
figure
headphones.
you could
too.
take it.
I have my headphones on, so that might be a problem.
Okay. There we go. Okay, so let's take the antiderivative. So this will be 0.17 x to the fourth over what? 4. And minus 2.9 x to the third over 3. Plus 10 x squared over 2. Plus 27x. Evaluated at 1 and 9. Now, if you want to go ahead and cancel, go ahead and do that. Somebody take 0.17 and divide by 4. What do you get?
0.0425.
0.0425 x to the fourth minus, take 2.9 and divide by 3.
0.967.
967 x cubed. I'll do this one for you. 5 x squared plus 27x, 1 and 9. All right, take off and do your algebra. And while we're at it, I'm going to take a highlighter and I'm going to highlight all the calculus. That little area right in there is the calculus. The rest of it's algebra. So, 0.0425 parentheses to the fourth, to the fourth power minus 0.967 x cubed. Oh, there's supposed to be a parenthesis there. Sorry. 967 parentheses cubed plus 5 parentheses squared plus 27 parentheses. Take my handy dandy window maker, copy, and go down here and insert. Bring that down. Heaven forbid you make something simple. I don't know. See if that's right. Hope I didn't mess up anything. Now, when you subtract, when you distribute the minus, it's going to make everything what? The opposite, Hubert. So that's a minus there, a plus there, a minus there, and a what? Minus there. So now I'm going to plug in everything. So I plug in a 9 here, a 9 here, a 9 here, a 9 here, and a 1 here, a 1 here, a 1 here, and a 1 there. Now, since 1 is so easy, I'm going to go ahead and do the 1. Let's go ahead and do the 1. So that's going to give us on the bottom minus 0.0425 plus 0.967 minus 5 plus 27. And I need somebody to do that for us. What do you get when you do the bottom part? 4 cent plus, that'd be 92 cent. 92 cent minus $5 is $4.08, whatever. $4.08 plus 27. No, it's going to be minus $4. I have no idea what it is.
22.9.
I'm sorry, what?
22.925.
22.925. Is that what everybody got? And it's positive or negative? Positive, right?
Yes, sir.
Okay, so that's it. So I'm going to take my blue one, and we're going to try to bumfuzzle through this. So somebody just do this first one for me. Okay, 9 to the 4th times 0.0425. What do you come up with?
278.8425.
278.8425. Okay, somebody do this second one for me. It's going to be a minus symbol, so don't worry about the sign.
704.943.
704.943. Anybody got that? Everybody got that? Okay. Plus 5 times 81. 400 and something. What? 405. And 27 times 9.
243.
243. Now somebody add up all those blue ones and give me that number.
221.902.
221.902. I need a second. Everybody, you agree with that? Check it again. I don't have a second.
Wait, okay.
278 minus 700 be negative 420 something. 420 plus negative 420 is negative. So it's going to be around 200 something because the 243 is going to cancel out. So what does it come out to be? I need somebody to verify the 221.902 or tell me something different.
I got 224, but I might have put something wrong.
Okay, now we got a 224. 224 what? Even?
224.98995. Let me check it again.
224.9 what?
95.
I think you're 701. You did the 0.967 to the 9. Yeah, that one. I think it's 704.
Okay, somebody check this.
Yeah,
9 to the 3rd power times 0.967. Check.
Yeah, it's 704.943.
0.9704. All right, now do the math and see what you get. I'm sorry, what?
I got 221.9.
Okay, we still got 221.9. What else? Okay, so we got, all right, now the one problem is we've got our numbers right, but we got something wrong. We got a sign wrong. Somebody take 221.902 and minus 22.925 for me. Tell me if you get 199 or 91 point. That's close enough. 191. What do you get? Just minus the 222.9525.
198.
What?
198.97.
Okay, we got something wrong because the answer by the book is 191.07.
Don't we still have to do the 1/8 from the
Did I not?
formula?
Okay, what?
The area formula, don't we have to do 1 over b minus a? So that would be...
No, this is just the area between two curves.
Okay.
Yeah, but that's good. I'm glad you brought that up. This is just area between two curves. The answer by the book, which I don't put a lot of confidence in, 191.07.
The 27
right.
at the very bottom where you have -5, shouldn't
Okay.
27 also be negative and not plus 27? It should be minus 27 if you distribute
Yeah,
the
I put a negative there. Did we
Well,
not
when you
do it that way?
Well,
All
when
right,
you
somebody
rewrote it at
redo
the
that.
top.
And subtract, make sure you subtract this 27 right here. That's a subtraction symbol.
Well, when you rewrote it at the top, you put a plus 27. So I didn't know if they were going off the top.
Oh, yeah, you might want to check that. Somebody check that bottom one, thank you. Check this one, redo this one. This is supposed to be a minus. I don't know why I wrote it as a plus. It's my fault. Just blame it on me.
I always do.
Exactly. If you do something wrong or something don't go your way, you
You give
don't
up.
you take it, you blame it on somebody else. Yes.
That's the American way.
Yes. No, it's not the American way. I'm not going to say which way it is, but it's not the American way. Just think about who blames everybody.
What happened to your hand?
Liberal.
I was moving a panel on the farm the other day and it had a piece of metal sticking out. And I was moving it and it cut my hand. I put diesel fuel on it. No, I'm just kidding.
Was the answer 191?
Did you get it?
Yeah, 190.825.
That's close enough for government work. But did we do this 22.925 wrong?
For that one, I got -30.990.
Okay, let's check that now. Negative what?
30.9905.
30.9905. Now subtract those two and see what you get.
$190.9115.
That's good enough. There's some rounding, but that's not a problem. So I would take that if you put it on the test. Somebody give me that one number again. 190 what?
190.9115.
92.
Yeah.
Go away. There we go. That's approximate. Now 191 against 190.92. It's close enough. Did you get that? Did you get 92?
Yeah, I got 190.8.
Okay. Anything around 190, 191, even up to 192, I would probably take those three answers. Now, let me tell you, in Calc 2, I don't care if you're in engineering calc or you're in business calc. Business calc will be a little bit more stringent, but you're talking about a rounding issue. Some of you probably didn't round to the second power. Some of you did. I have no idea what they rounded to. Looks like they rounded to the third. If you went through and rounded to the 10th place like your calculator does, and you keep storing those 10 place values in there in the stow function, then you would probably come out with this number right here. But most of y'all probably didn't do that. Most of you probably wrote down and rounded to the second or third power, third decimal place, and then you repunch that number in. So, you might want to remember the stow function, especially if you were in my class the last couple of semesters. We used the stow function to where, you keep that 10 digit in there and then you bring it back up, but that's up to you. So I would take anywhere from 190 to 192, but I'm going to tell you right now, in a lot of Calc 2 classes, the only thing they want you to do is set it up right here. They either want that answer, they just want you to set it up most of the time. But, with area between two curves, usually they want you to do it. All right, let me find another one. Here's another one. This one. And we'll move to the average. I'm going to do 2 problems out of 5.7, and we'll do 2 problems out of 5.8, which is area, I think. All right. So f of x And the only reason I'm doing these out of the book is to show you what it's going to look like, the difference between the problems that we do over and over and over and the problems they give you in the book, which are kind of aggravating. 3.7, 1.194 to the x power. And g of x, 0.04x cubed minus 0.54x squared plus 2.5x plus 4.47. And whoever caught that error a while ago when I put it up there, thank you. Whoever caught that plus 27, thank you.
You're welcome.
No problem.
Yeah, whatever. Your voice ain't high enough. How many of y'all watch the cheesy sci-fi horror movies? Anybody watch them?
Sometimes.
They're so cheesy. Well, Lake Placid, the last Lake Placid movie was on this weekend. Me and my son watched it. It was cheesy.
What are the coordinates for this one?
I'm sorry. 0 to 10. 0 to 10.
It's X. Yeah.
Better graph this one. Because you're going to have to do something funky with this one. Graph it before you do anything. Well, you don't have to do. I mean, you don't have to do anything funky. You just want to show you something different.
Thank you.
Bless you.
Thank you.
They do want you to find the intersection point. And you can do that with the graph, or I mean, you can do it with the graph on this one, or you can do it with the algebra. I would suggest the graph. There is an intersection point. So I want you to make sure, one, we're not going to do it, but I want you to be sure you can graph it. And two, make sure you can find the intersection point with your calculator, okay? The reason I want you to be able to do that, if I give you this question on the test, you know, all I care about is the area. But they may ask you to graph it, and they may ask you to find the intersection point. But just make sure you can do that, okay, on your calculator. All right, so we've got antiderivative from 0 to 10 of 3.7, 1.94 to the x power minus parentheses 0.04 x to the third minus 0.54 x squared plus 2.5x plus 4.47. Okay, there's no way you're going to be able to calculate this into everything, but you can distribute that negative. So from 0 to 10, 3.7, 1.94 x power minus 0.04 x cubed minus 0.54 x squared, that's going to be a plus, sorry, and then minus 2.5x minus 4.47. Now I want you to break up. You don't, I mean, if you want to break it up, I would break it up into separate terms with the antiderivative. It might make it easier for you. And remember how to take the antiderivative of the x term. If not, I'll remind you. But go ahead and break it up. Pull out that 3.7. Pull out that 0.04. The reason I'm telling you to do that is when you get to a point when you think you're getting confused, what should you always refer back to? The basics. Always refer back to the basics. And the basics tell you that when you have an antiderivative or derivative, you always go back to the basic rules, which means pull out and break up. So, I'm going to, even though it's a little bit tedious, I'm going to say 3.7 antiderivative from 0 to 10 of 1.94 x dx. Okay? Minus 0.04 antiderivative of x to the third dx. Plus 0.54 antiderivative of x squared dx. Minus 2.5 antiderivative of x dx. And then minus 4.47 antiderivative of x to the 0 power dx. That's x to the first power. Okay, now I did everything just back to the basics. And yes, I know I'm supposed to put 0 to 10, but that's really not my point of not trying to bring that point home right now. I'm trying to bring point to home of breaking it up, because you know how to do. If you're gonna fluctuate on anything, it's gonna be this guy right here. All right. So what you need to do is you need to go ahead and break it up to where you say, okay, well, I remember 90% of this. I just got to remember this, and I know it has something to do with a log, okay, because it's an exponent. So let's go back to our cheat sheet that I gave y'all back in 130. I'm just going to pull it up because this is what you ought to do. Go to the handy-dandy derivatives, antiderivatives cheat sheet. Type in derivatives / or antiderivatives. I can't spell worth a flip. Antiderivatives worksheet. Doesn't have to be worksheet. It could be, and then hit images. And you'll see, find a good one. I had the good one picked out for y'all last semester, but I don't know where it is now. But just find a cheat sheet. Maybe we should call it a cheat sheet. Let's go with cheat sheet. There's one right there. Of course, you can't hardly see it, so you need to pull out one. There we go. All right, find x to the n power, or not x to the n power, but there it is right here. So write that one down. If you have a function to the x power, that's the function to the x power over the natural log of the function, or the constant. So n to the x over the natural log of n. So there you go. Without spazzing, without having a, attack, you take the dang old snipping tool. Well, there we go. And we'll just pull that out. Okay, what happened? Hold on a second. Something happened to my cheat sheet. I hate these websites you go to and it just does all kind of funky things. Like I said, it's a conspiracy. There we go. Let me go back to the snipping tool. Pull it out for you. Where is it? There it is. So you go to your handy dandy cheat sheet that I gave you last semester, that 1 out of 30 probably printed out. And you come back here. Well, I'll just pull it over here. There it is right there. So you take that cheat sheet, whatever, and what does it come out to be? 1.94 to the x power over the natural log of what? 1.94. So I'm going to rewrite this as 3.7. And now I'm going to just put a parenthesis here. And I'm going to put, what? 1.94 to the x power over the natural log of 1.94. Well, what can happen to that 1.94? It can come back out.